All right. The next one is an argument. This is a quantified argument. It's got all, some, and some. So for those, we're going to want to use diagrams. And the best way to do this one is, I think, to get a piece of paper and attempt to determine the validity or invalidity on your own. And typically the most efficient way of doing this is to look for, this is equivalent to our bad row method, is to look for a bad row. Now, since we're not doing a truth table for these, it doesn't really make sense to say a bad row, but the idea is the same. We're looking for a case where this is true and this is true and this is false. And again, the fact that you agree or disagree with the conclusion has no bearing on whether the argument's valid or not. Soundness and validity are two different things, so don't worry about the individual truth or falsity of these. We're trying to determine that whether, if these are true, then will this necessarily be true? And we're going to see if we can find one case where it fails, because if we can't find a case where it fails, then we know this argument must be valid. So let's try this. All farmers are men. We're going to draw a picture in which the farmers are inside the set of men, just like that. Okay, all farmers are men, and you might say, well, that's a false statement, but who cares? The next one is some women are farmers. So we're going to have a set of women somewhere out here. And the set of women has to intersect the set of farmers. There has to be at least one person in here who's a woman. And so we have to draw the set of women so that it encircles that dot. And we're trying to see if we can avoid getting some women to be men. And no matter how you draw the set of women, whether it's inside here, the place where women intersects farmers must contain a woman who is a man. Okay? It's impossible, if these are true, for this to be false. And so the answer is there isn't a bad row, so it must be a valid argument. Okay? Let's see what we have here. And we see this one was what's called a strong distractor. And the problem with this one is that in fact both these pictures are the same. This has the argument and being valid actually. So you want to be careful. I think the best bet is to not worry about these pictures. Make your own picture. It's not often in real life we have multiple choices. So the correct answer in this case would be B. The next one is a symbolic argument, and the food will taste good, and that would be, say, P, or we will send it back, Q. The food did not taste good, that would be not P, therefore we will send it back, Q. P or Q, not P, therefore Q. It's not that one. It's either this one or this one. Okay, and you can toss these two out just because they have the wrong diagram. Now again, in contrast to this one, we determined whether it was valid or invalid, and then we compared our picture to these. Okay, so I really should have just been comparing these two right here, because once I determined the argument was valid, then I didn't need to worry about this one or this one. If it's valid, it has to be this answer or this answer. And this answer just doesn't work because, for example, it doesn't satisfy this. If you're showing an argument's valid, you show that no matter what happens, if these are true, this must be true. That when you make these true, you cannot avoid making this true. Well, this person hasn't even checked because the second premise, some women are farmers, isn't true here. So this can't be supporting a valid determination of the argument. Okay, back to this one here. So we're left with these two choices, valid or invalid. There's two ways to do this. One is to say it's valid by pattern, and this is a valid pattern, or we can do a truth table or a bad row. The truth table would give us a nice long list of columns, helper columns, etc. We'd have P or Q, we'd have not P, we'd have P or Q and not P. We'd have, I'll copy Q here, just so we can make our life a little easier. And then finally, our argument itself will be this column, which is P or Q and not P imply Q. And if that last column is all trues, it's a valid argument. If there's a single false, it's an invalid argument. So let's check true, 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 false, false, true, false, false. P or Q, true, true, true. Oh, it always helps if you have different ones here. True, 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 and false. The negation of P column would be false, false, true, true. And the conjunction or the anding of these two would be false, false, true, false. I just copied the Q column over here. True, false, true, false. And now we want to check the implication. F arrow T, and again, false arrow anything will be true. And we can see from this, it's what's called a tautology. That means always true, and it is valid as a result of this. Now, alternatively, you can see here, there are no bad rows. Alternatively, we could attempt to find a bad row, and we know in advance that we're going to fail, but let's just go ahead and watch this happen. That if we're trying to find a bad row, that is, can we find a case where P or Q is true, not P is true, but Q is false? Well, let's look at our possibilities. We have P and Q take on as a pair any one of these four values. We know that this bad row can only occur if Q is false. Well, so we don't need to consider the cases where Q is true. We only need to worry about the cases where Q is false. And further, if not P is true, then we know that P itself is false. So the only way a bad row can occur is if P is false. So we don't need to worry about the cases where P is true. So really we're only down to one case. And let's see if this is the case that will give us our bad row or not. And we're attempting to see whether we have a true, and a false. Well, we have our false here, we have our true here. And then we get up here, we see that P or Q is not true. So we couldn't achieve that. We cannot find a bad row. So that means the argument is valid. Okay.